I'm Matthew Weeks, root9B Senior Research and Development Scientist, and I wanted to talk to you about Petya today. Now, you may have heard of Petya or not Petya, or Eternal Petya as it's called, since it's a new variant of something that looks like the Petya ransomware. It was a worm that recently hit a lot of companies around the world and caused a lot of damage. We were curious to see how it might fare against root9B security offerings, and so the first thing we did was to see how it would function against Orkos. So what we did was we stood up a small test domain of different Windows systems, and then we installed Orkos on a system and ran a scan of that domain with Orkos. So we entered in our credentials. Now this domain has only two workstations in it and a domain controller, just for the simplicity of this demonstration. One of the workstations should be of an ordinary user. The other workstation is of a domain administrator. And then, of course, the domain controller has the credentials to all of the users on the domain. Normally, you wouldn't expect that the limited user Windows 7 system would be able to gain access to the entire domain. But once we run this scan with Orkos, it calculates all the group memberships, reused credentials, local accounts, domain accounts, privileges, and goes ahead and puts together this risk display for us. Now, this risk display has all these nodes in red. That means they're high risk. So by clicking here on this Windows 7 system, we can see how can this system take over the entire network. And we can alter our view settings to make that a little bit easier to see. And we can see that first, how does that happen? Well, the local admin account on that system shares a password with the local admin account on the admin's box, that's the other workstation. And by reusing that stored credential, the admin would be able to take over that domain admin system, then steal the domain admin credentials and take over the domain controller. Then once you had access to the domain controller, you could steal credentials to anyone else on the domain. We can also, as you can see, alter the layout of the display, and you can drill down and see how it detected all these credentials, where they were stored, how the privileges work out, how a particular node has rights over a particular system with permissions, whether to allow or deny permissions, and how all that works. The other thing we can do is we can create what's called a scenario. And a scenario will let us figure out how to remediate these issues. We'll go ahead and run an analyzer. In this case, it's a fairly simple network, but when you have thousands of nodes, having it automatically identify the most critical links is very important. As we can see, sure enough, it has identified that the top critical links are, sure enough, that local admin account and that domain admin account. And so if we look at those local admin accounts with their reused password, we say, hey, let's simulate what would happen if we randomized their password or changed it so it was no longer reused. Now we can go back and look at our network and say, hey, look, now our Windows 7 system is no longer high risk. The only high risk nodes are the nodes that are the domain controller or the administrator system. And we've seen how to remediate that. So now let's see what would happen if we did not have Orkos, we did not identify those risks, and we were unable to remediate those. So what we'll do now is, you see the screen for the limited user's Windows 7 account. What we're going to do is launch the not Petya ransomware using run DLL. That DLL disappears, and then we'll flip over to the admin system where we have a packet capture going, and we can see what happens. Petya has attempted to log into the system with one of the tokens that it stole from the original system. That didn't work because that limited user, Alice's account, didn't have permissions to take control of this system. But it'll keep going till here we see a bunch of packets hit the screen. It has stolen the local administrator's token and the credentials from that local administrator account and used that to gain access to that admin share on 56.11. That's the IP address of the admin system. Now it is running code on the admin system, and it will very quickly steal the credentials to the admin's account and hit 56.2, which is a domain controller. So the first attempts fail again. Some of those credentials don't work, but it keeps looking for new credentials and then tries again. Here it gets another access denied. The next thing it's going to try to do is steal the domain admin's token, and sure enough, we see these KRB5 packets. It's okay, don't worry if you see those scroll by. That's it authenticating to the domain controller, and then right here you see it writing perfc.dll to the domain controller's admin share. That means it's now got admin access to that system. and now that it has access to that system, it creates psexec service, since it's using psexec to gain access to that system, and it has control over the entire domain controller. We flip over to the domain controller virtual machine, open up a task manager, look through the process list, and sure enough, there's run-dll32 running. In this case, that run-dll32 is running the malware, which was packaged as a DLL. And so just in a matter of seconds, we've seen this ransomware cycle through accounts, stealing all of the credentials that it can, testing them against all the systems in the subnet, obtaining access to additional systems, and then using that to spread out through and take over the entire domain. A very effective technique, which is used by a lot of penetration testers and other hackers as well, and frequently results in complete domain compromise. In our tests with Orkos, we've identified automatically a path to domain admin, such as in the same manner or a similar manner that Petya uses or could be used to take over the entire system from usually between 75 and 99% of systems and most of the domain accounts as well. And so this is something which is hopefully a warning sign to you, since this can happen and most likely would happen if someone gets in that position via credential theft to take over your entire network and cause an enormous amount of damage throughout that network. So I hope this was instructive and shows you how Orkos can identify the risks and help you remediate the risks that were used by the Petya ransomware